Next, we will do the second part of subpart A. So the second part asks the probability that a sample mean takes on a value between these two numbers. So if I imagine, so basically in real life, we usually only take one sample. So you only have one and only one sample mean. So you are asking, so if I take one and only one sample mean, what are the chances that my sample mean takes on the value between this and that number? So what are the chances that my sample mean falls within a certain range? Okay, so that's the basic idea of the second part. Okay, let's get back to the demonstration. Here it is. So the second part, the first thing is you have to be very clear what the question is asking you exactly. So let's write this out mathematically. So the question, the second part is asking you to find the probability, meaning proportion or percentage, such that your sample mean falls within two numbers. So I think the two numbers are 180 and 184. So let me move this higher so we can see that. Okay, so what's the proportion of all sample means that fall between 180 to 184? So you can think about this as what's the proportion of all sample means that lie between these two values, or what's the proportion of your sample mean, the one that you are having, that falls between these two numbers. The next thing is to draw the diagram to make sure that we are clear what we're supposed to do. Now the method to find that probability is very similar to the concept, or one of those concepts that we have in chapter 3. Okay, so first of all, we draw the histogram of sample mean. The middle part is 182. So basically, we are asked to find how big this area is. So what's the proportion of all sample means that fall between these two values? So to find that area, like before, we're going to rely on this z table, the z curve. The middle point is 0. So we have to find, so this is 180, this is 184. So we have to find the corresponding z values. Okay. So make sure you draw these two diagrams. Now next, we have to do the calculation, and which is actually not difficult, but we have a new formula. So let me jog your memory a little bit. In chapter 3, we have this formula. Z is equal to x minus mu divided by sigma. So the more we understand, the less we have to memorize. Okay, so let's take a look at this formula again. X minus mu, you are comparing x, an individual observation, with mu. What is mu? Mu is the mean of all x. And you divide it by standard deviation. Standard deviation of all x is sigma. Now, so by using similar concepts, now in chapter 15, we are concerned with x bar, not x anymore, x bar. So we want to measure a sample mean with the center of all sample means, meaning that we want to measure x bar with mu, because mu is the mean of all sample means. And we want the denominator to be the standard deviation of x bar, not x anymore. So the standard deviation of x bar is sigma divided by square root of n. So this is the new formula that we're going to use from now on. Okay, so let's get back to here. So what we need to do is, for each x value, we have 2, 180, 184, we have to use this formula to convert that, I'm sorry, not x value, that x bar into z. So let's do this. So z is equal to, take 180, that's our first sample mean, subtract mu, mu is 182, divided by sigma, sigma is 37 divided by 100. So we know this number actually is 3.7. So use your calculator, that z value is going to be 0. It's negative, right? Because 180 is smaller than 182, negative 0.5405. Okay. And please also draw a diagram. This is, let's do a better job of the diagram. This is kind of like a, doesn't look like a bell-shaped curve. So. Okay, better. Let's do z here, actually. Let's do z here. The middle point is 0. So when z is negative 0.5405, what is the corresponding left area? If you look at your table, this number, this area would be 0.2946. Okay. Now, so you just repeat the procedure again. Find the z for 184. So when x bar is 184 minus the mu divided by 3.7, this time we will have the positive number because 184 is bigger than 182, 0.5405. And then the diagram that we're going to have is like this. Z, this part is 0, and this is 0.5405. And you look at the table to find the left area, left of positive 0.5405, and that area is 0.7054. Okay. Now, so this step 2. The activities that we did in step 2 actually were very similar to those that we would do in chapter 3. Now that you have two areas, one bigger than the other, then to find the middle area, you will have the bigger area subtract the smaller area, right? So we will have 0.7054 subtract 0.2946, right? So this is a bigger area. You subtract, so imagine this big area, you chop off the tail, then you will give you back the middle area. Okay? So this is equal to 0.4108. And that actually is our answer. So the probability that a sample mean takes a value between 112 and 118 is 0.4108. So roughly 41% that then your sample mean will fall between these two numbers. So this is how you would do the second part of subpart A. Subpart B is very similar. They just give you a different sample size, 1,000. Okay, so just follow the format of A to do B.